Seminar number 16, Statistical Nuts and Bolts, Part 1. Statistical analyses are used to infer truth in the universe because it is impossible to enroll the entire human population in a trial. So statistics are used to infer truth from a sample. The infamous p-value is what most folks associate with statistical truth. So let's categorize statistics as descriptive or inferential. When we use descriptive statistics, just the quantitative summary of data is reported. Just the facts are reported, the demographics or counts or other observed information during the course of a study. Whereas inferential statistics uses procedures to draw conclusions from data, whether it's an association or a difference. These are tests of significance. The null hypothesis is the basis for tests of statistical significance, or tests where inferential statistical calculations are made. The purpose of most studies is to ask, is there enough evidence to reject the null hypothesis in favor of an alternative hypothesis? In other words, investigators hope to prove the null hypothesis wrong. To challenge the null hypothesis, tests of statistical significance are performed to determine whether study observations are due to the intervention or to chance. When we talk about chance in science, in statistical terms, we mean probability. By convention in statistics, probability is normally expressed in terms of doubt. By convention, 5% doubt about the result being true is considered acceptable. This 5% is expressed as p equals 0.05. Remember, p equals probability. To say this in another way, if the p-value is less than 0.05, we reject the null hypothesis as false and conclude our study demonstrates a statistically significant difference between the groups. Remember our jelly bean example from the start of this session, where no link was found between jelly beans and acne because the p-value was greater than 0.05? The null hypothesis in that study was not rejected. This p-value does not tell us about clinical significance, nor does this p-value tell us about the magnitude of difference between two groups. Even the most sophisticated statistical gymnastics cannot salvage a poorly designed study. So it is important to think about your statistical support before you start your study. Consider getting a statistician to help you out, because a statistician can help you with study design, can help you select statistical strategies before you've collected your data, can help with sample size calculation, can help you develop data collection instruments, can help you plan your data analysis before the data has been collected, and can help you prepare tables, graphs, and other figures. Having access to a statistician can be incredibly helpful, but some departments cannot afford a full-time statistician. So some departments end up sharing one with another department. If your department does not have one, consider finding one at a university campus. This is really important because many journals now include a separate statistical review as part of the manuscript evaluation process. Sample size deserves a brief comment here. A sample size calculation is essential to report in any manuscript that uses inferential statistics. It tells us whether or not the number of subjects is enough to determine statistical significance between groups. To calculate a sample size, you need to decide the effect size considered significant in your study. You also need to choose your alpha, the probability of making a type 1 error during the course of your study, and you need to choose your beta, the probability of making a type 2 error during the course of your study. Remember, no study is perfect. We need to balance feasibility with validity and minimize errors, but it is impossible to completely eliminate them. A type 1 error is when you reject the null hypothesis when it should have been accepted. This is also known as an alpha error. By convention, 5% is deemed acceptable. A type 2 error is when you accept the null hypothesis when it should have been rejected. This is also known as beta error. By convention, 20% is deemed acceptable. Power is related to the study sample size. This is the probability of rejecting the null hypothesis in a sample if the actual effect in a population equals or exceeds the effect size. Power equals 1 minus beta, which by convention equals 1 minus 0.20, which equals 0.80 or 80%. These are the fundamentals of sample size and power. For more, please read the appropriate chapters in Hulley. So if planning on using any inferential statistics, calculate sample size ahead of time. Even pilot studies need a sample size. Smaller effect size requires a much larger sample, and plan for dropouts or cases with incomplete data. In the next seminar, we will continue our discussion of statistical nuts and bolts.